Hello guys, welcome on Tesla Eduventures. In this video, we are going to discuss the concept illustration problems of AC and of level 1 for JEE Mains and NEET. And in this very first question, you can see that there are three circuit elements L, C and R in such a way such that XC and XL are equal. Okay, and we have connected them into three different cases. The first one is a series combination of R and C. The second one is the series combination of R and L, and the third one is the series combination of L and C. Okay, these are the three combinations in which they are connected. Now, obviously, we can say that if this circuit is 1, this is 2, and this is 3. We can say that if XC and XL are equal, therefore Z1 and Z2 will be equal. And let's suppose that they are Z. So the average power loss in first one is VRMS, IRMS. IRMS can be written as VRMS by Z. And cos phi in the first one is XC by, in fact, I'll directly write down the cos phi. Cos phi will be XC by Z. And the power in the second one, obviously this power is average power loss. So it would be VRMS, and IRMS is again VRMS by Z, and cos phi is XL by Z. And the third, the power loss in the third circuit will be 0 because there is no resistance present in that third circuit. So we also know that XC is equal to XL, therefore P1 will be equal to P2. And if P1 and P2 are equal and obviously P3 is 0, then we can say that the correct answer would be third one. Now let's move on the next question. In this question, you can see that there is a series LCR circuit, and in this circuit, we have to find out the potential difference across A and B terminals. We can see that these terminals are the terminals of inductance and capacitance, and VA minus VB is actually equal to the net voltage of L and C. And in series LCR, we know that this is a series circuit and current remains same. So I current will be on x-axis, VR will be on x-axis, VL will be on y, and VC will be on minus y. So the resultant of VL and VC will cancel out, and therefore we can say that the net voltage of VA minus VB will be 0. So the correct answer is 0, fourth option. Now we move on the next question. In this question, you can see that there is a series combination of R, L and C. This is a series LCR circuit, and across each of these elements, a voltmeter is connected, V1, V2 and V3. Now, it is also given in the question that XL, XC and R are equal, and each of them is equal to 10 ohms. And the voltmeter has a voltage, we can say that it is a RMS voltage. So it has a RMS voltage of 300 volts. So now we have to pick the correct options regarding the probable readings of these voltmeters. So first of all, we can say that if XL and XC are equal, then there will be resonance condition in this case. And due to the resonance condition, we can easily predict that VR, the voltage across resistance, will be exactly equal to the net voltage. And net voltage is 300 volts. Okay. And obviously we can say that the current through all of these elements will be same because they are connected in series, and obviously we are considering these voltmeter as ideal, so there would be no current withdrawn into those voltmeters. So if XL and XC are equal to each other and they are equal to R, therefore we can also say that VL will be equal to VC and that would be equal to VR. And obviously, as we have already discussed, that VR will be equal to 300, so they will be equal to 300. So all of these three voltages will be equal to 300, and therefore the correct answer would be fourth. Now let's move on the next question. In this question, you can see that this is a series LCR circuit, and an oscillator of having RMS voltage of 220 volt is also connected in this circuit. In this circuit, we have to find out the resonance frequency, as well as we have to find out the amplitude of the current at resonance condition. See, first of all, it is very important to note that the resonance in resonance condition, we know that omega r is 1 upon under root LC, but this omega r is not the frequency, it is the angular frequency. Okay, and in this case, you can see the unit of the frequency. It is radian per second. So obviously, it is mentioned that we have to find the frequency, but actually we have to find out the omega. By seeing the unit, we can predict that we have to find out the omega. So omega resonance is, if we have to find out the frequency, we know that omega resonance will be 2 pi f. Okay, so omega resonance will be 1 upon under root of LC. Now L is 8 into 10 raised to power minus 3, and C is 20 into 10 raised to power minus 6. Okay, so omega resonance will be equal to 1 upon under root of, this is 16 into 10 raised to power minus 8. So omega resonance will be equal to 1 upon 4 into 10 raised to power minus 4, and this will be equal to 1000 upon, in fact 10,000 upon 4, that is 2500 radian per second. As well as if we wish to find out the amplitude of the current, then it would be equal to V naught by R, because in resonance condition the impedance of the circuit becomes equal to the resistance, but obviously the RMS voltage is given. See, it is not mentioned in the question that this is RMS voltage, but we have already discussed that if nothing is given about the source voltage, we consider it as RMS voltage by default. So we will be considering this voltage as RMS voltage, and therefore we will be finding out the RMS current. So IRMS will be equal to VRMS upon R, because that is R. So IRMS will be equal to VRMS is 220 upon R, where R is the resistance, it is 44. So IRMS will be equal to, this is 10 and this is 2, so it will be equal to 5. And I naught will be equal to IRMS into root 2. So I naught will be equal to 5 root 2. So the correct answer will be option 1. Now let's move on the next question. In this question, you can see that there is a series LCR circuit, and we have to find out the power factor of this circuit. Okay, so if we are discussing about the power factor, we know that power factor is equal to cos phi, and we also know that cos phi is R upon Z. Now Z in this circuit will be under root of, Z will be under root of xl minus xc whole square plus r square. So z will be under root of 80 square plus 60 square. So z will be equal to 100. So r in this case is 60 and z is equal to 100. So cos phi will be equal to 3 by 5. Now let's move on the next question, and the correct answer of this question will be first. Now let's move on the next question. In this question, you can see that this is a series LCR circuit, and in this series circuit, the voltage across this inductor and the voltage across this capacitor is equal, and obviously therefore there will be a resonance condition in this circuit, and in the resonance condition the circuit will be behaving like pure resistive, and the current flowing in the circuit will be V by R. Okay, and now if we change the value of current, value of the resistance, then value of current will change, and the value of VC will be IXC, and therefore it will change, and value of VL will be IXL, and hence the value of VL and VC will change. But you should remember that when we studied the phasor diagram of series LCR, we observed that these three voltages were like this, and the voltage across inductor and capacitor were opposite to each other, and therefore the resultant of their voltage will be zero. So the net voltage across VLC will be zero, and it will stay zero. If you will increase the current, let's suppose you are increasing the current by decreasing the resistance. So if you will increase the current, the voltage across inductor and voltage across capacitor both will increase, but they will always be equal to each other. So the voltage across the LC combination will be zero always. So the correct answer will be option C. Now let's move on the next question. In this question, you can see that there is a circuit, RC circuit, in which R and C are connected in series to the AC source. This is C and this is R, and this is AC source. And the current registered in the circuit is I. Now, when the frequency of the source is changed to omega by 3, the current in the circuit is found to be halved. Then the ratio of reactance to the resistance at the original frequency will be. See, first of all, we can say that the current in the circuit initially will be I will be equal to V upon Z. Okay, and we know that Z is under root of XC square plus R square, and obviously XC is equal to 1 by omega C. Okay, and now we have decreased the frequency from omega to omega by 3. So the new current becomes I by 2, and it is V upon under root of now XC new will become thrice of old XC. Okay, so it would be 9 XC square plus R square, and I is V upon under root of XC square plus R square, and there will be 1 by 2 also, and it is equal to V upon under root of 9 XC square plus R square. Cancelling V with V, you can see that if we square both the terms, then 9 XC square plus R square will be equal to 4 XC square plus R square. Okay, and therefore this 9 XC square plus R square will be equal to 4 XC square plus 4 R square, and 5 XC square will be equal to 3 R square, and XC upon R will be equal to under root of 3 upon 5. So the correct answer will be option number 1. Okay, now let's move on the next question. In this question, you can see that there is a graph, which is there are three graphs in fact. One of the graph is XC versus frequency, the other one is XL versus frequency, and the third one is R versus frequency. Okay, so we have to find out the point where the circuit will be inductive. So we know that circuit is inductive at the point where XL is greater than XC. And I can see that at this point, you can see that this is XL and this is XC. So XL is greater than XC at point C. So circuit will be inductive at point C. So the correct answer is C. Now we move on the next question. In this question, you can see that there are three resonance curves. You can see the three curves, and the peak of all of the three curves is different. And we know that the peak of the resonance curve is I naught max, and I naught max is V naught by R. So the graph in which peak is at lowest, this graph has a peak at lowest, will have the greatest resistance. So R3 will be greatest, then it will be R2, and then it will be R1. So the correct option will be option B. Now we move on the next question. In this question, you can see that there is a RC series circuit which is connected with a voltage source, that is V naught sine omega t, and it is given that R is equal to 1 upon omega c initially, and the peak value of the current is I naught. So we can say that the peak value of the current I naught will be equal to V naught by Z, and Z initially will be under root of R square plus XC square. Now as you can see that R is equal to XC, then surely we can say that Z is root 2R. Okay, this is Z. And now if we say that if we uh, write down the value of I naught, it would be V naught by root 2R. And obviously if R is equal to XC, we can say it is V naught by root 2 XC. But now when the frequency has been changed to omega by 3, omega by root 3, XC will also change, and as XC is inversely proportional to omega, therefore we can say that if omega new is omega by root 3, then XC dash new will be root 3 of old XC, and therefore Z2 will be equal to under root of R square plus XC dash whole square, and Z2 will be under root of this R is obviously equal to old XC, so this is XC square, and XC dash is root 3 times of this, so this is 3XC square. So Z2 will be equal to 2XC, and I naught dash will be equal to V naught by Z2, which is 2XC, and V naught by XC is equal to I naught. V naught by root 2x is I naught, so it is I naught by root 2. So the correct answer is I naught by root 2, which is option B. Now we move on the next question. In this question, you can see that there is a circuit containing L, C, and R all in parallel, in series to each other, and they are connected to this voltage source. So we have to find out the value of VA minus VB as a function of time. So first of all, let us see that XL is omega L, and omega is 100 pi, so it is 100 pi, and L is this, so this is 1 upon 100 pi. So XL is 1, and XC is 1 upon omega C. So XC is 1 upon omega. Omega is again 100 pi, and C is 1 upon 500 pi. So XC is 5. Okay, this is the value of XC. Now Z is obviously Z will be under root of XC minus XL ka whole square plus R square. So Z will be equal to 4 square plus R is, I think, R is 3, yes. So 3 square. So Z will be equal to 5. Okay. So if we draw a impedance triangle, then we will draw the resistance on x-axis, which is 3. We will draw XC over here, and it would be equal to 5. In fact, this would be XL, and this will be XC, it is 1. So we can see that the resultant of, uh, in fact, XL is 1, XC is 5. So the resultant of XC and XL is XC minus XL, and it is 4, and this is 3. So the net impedance Z is 5, and this angle is phi. So tan phi will be equal to XC minus XL upon R. So tan phi will be equal to 4 upon 3. So phi, we can see that phi will be equal to 53 degree. Okay, this is the value of phi. And we can see that if we draw the phasor diagram, then phasor diagram will look like this. Here will be VL, here will be VC. And as we know that VC is greater than XC is greater than XL, therefore VC will be greater than VL, and the resultant of VC and VL will be VC minus VL. And the net voltage will be on this axis like this. This angle will be 53, this angle will be 37. So VC minus VL, which is the voltage across A and B, is behind the net voltage by an angle of 37 degree. So we can, first of all, this is, and we can also find out the value of I naught. I naught will be V naught by Z. Now V naught was 10, and Z is 5, so I naught is 2. And if we need to find out the peak value of VC minus VL, then it would be I naught into net impedance, which is XC minus XL. So it is 2 into 4, which is 8. So VC minus VL will be equal to 8 cos omega t. Now you can see that VC minus VL is behind V by an angle of 37 degrees. So it would be minus 37 degree. So the correct answer will be option C. Omega will remain the same. Now we move on the next question. In this question, you can see that there are three elements L, C and R which are connected in series with this voltage source. The voltage across capacitance is 400 volt. The voltage across inductor is 400 volt. And we have to find out the voltage across this resistance as well as the current flowing in this circuit, which is measured by ammeter. So you can see that if VC and VL are equal, then this means that this circuit has a resonance, and in resonance the net voltage occurs on the resistance only. So the net voltage, which is 100, will be equal to the VR, and VR will be the reading of V. So reading of V will be 100. As well as circuit is behaving like pure resistive, therefore current I will be equal to V upon R, and V is 100 and R is 50. So current will be 2 ampere. So the correct answer will be A. Now let's move on the next question. In this question, you can see that the power factor of this circuit is 1 by root 2. Then we have to find out the value of capacitance. As we know that power factor is cos phi and it is 1 by root 2 and it is R upon Z. So we can say that Z will be equal to root 2R and Z is under root of XL minus XC whole square plus R square and that is root 2R. So we can say that XL minus XC whole square is equal to R square. Okay, and XL minus XC will be equal to plus minus R. Now XL is omega L and omega is 100 and L is 0.1. So XL is equal to 10 and R is also equal to 10. So we can see that if we will write 10 minus XC is equal to 10, then XC will become 0, but there is no option which is matching with this. So obviously we can think that this would be minus 10 and XC would be 20. And if XC is 20 and XC is 1 upon omega C, so C will be equal to 1 upon 20 omega. And this is 1 upon 20, omega is 100. So C will be equal to 500 microfarad. So now we move on the next question. In this question, you can see that there is a combination of L, C and R and this is a series combination. And across each of the element, the voltmeters are connected like this and all of the voltmeter are ideal voltmeters. Okay, and we have to find out the correct option. So it is also given in the question that we have to consider the resonance condition, and we know that at resonance condition VL and VC are equal, and in this case VL is V2 and VC is V3. So V2 is equal to V3. Okay, and the net voltage V net is always across the resistance, and therefore we can say that the net voltage, obviously net voltage in this case is V4, because if you can see that if A and B are these terminals, then A and B are exactly the terminals of this oscillator, and therefore we can say that the voltage across this oscillator is Va minus Vb, and obviously the voltage across this voltmeter is Va minus Vb. So we can say that V4 will be equal to V net, and at resonance the net voltage is always occurring across the resistance, so V net will be equal to V1. Okay, so this is the important thing, and also obviously the correct option will be option number 4 because this option is not mentioned in the question anywhere. So the only correct option is 4th. Now we move on the next question. In this question, you can see that this is a circuit in which this inductor and resistance are connected in series and this capacitance is connected in parallel to both of them, and they are connected in parallel with this AC source, and we have to find out the phase difference between I1 and I2. See, in these kind of questions in which any two elements are in series and the third element is in parallel with their combination. So in these kind of questions, we have to draw the two phasor diagrams. The one phasor diagram is local phasor. So this is local phasor, and in local phasor diagram, we will draw the phasor diagram of this circuit, which is connected in a single branch. So in this local phasor diagram, as we can see that inductor and resistance are in series with each other. So current will be on the x-axis because in series combination, current is the same factor. The voltage across resistance VR is along the current like this, and the voltage across inductance is ahead of the current, like this, and the net voltage V will be ahead of the current by a phase of phi. Let us suppose that it is phi. So tan phi will be equal to VL by VR. VL is IXL, VR is IR. So tan phi will be equal to XL by R. This is tan phi. Okay, and we can see that the resultant voltage is ahead of the current. This is I2 by a phase of phi. Now, if you draw the global phasor, so in the global phasor, we can see that this circuit is actually a parallel circuit, and in any parallel circuit, we always use the voltage as reference because voltage is same in any parallel circuit. And obviously we can see that this current I2 is behind the net voltage by a phase of phi. So I2 will be drawn here, and this is phi, and I1 is the current flowing in the capacitor, and we know that the current flowing in the capacitor is pi by 2 ahead of the voltage across the capacitor. So the current will be drawn here, I2, like this, and the net phase difference between the current I1 and I2 will be theta, and theta will be tan, in fact theta will be pi by 2 plus tan inverse XL by R. Okay, so this will be the phase difference between I1 and I2. So the correct option will be C. Now we move on the next question. In this question, you can see that there is a circuit in which these three elements L, C and R are connected in series to a voltage source whose time dependent function is 20 cos 2000 t, and there is a emitter connected in the circuit. So first of all, we have to what we have to find is the voltage reading across L and C and the current reading in the circuit. And we have to assume the voltmeter and emitter as ideal. So first of all, let us find out the value of XL and XC. So XL is omega L and omega is 2000 and L is 5 millihenry. So XL will be 10 ohms, and XC is 1 upon omega C. So 1 upon omega is again 2000, and C is 50 into 10 raised to power minus 6. So XC will be 10 to the power 6 on the numerator, and in the denominator it is 10 to the power 5. So it is 10. Okay, and the value of R will be 6 ohms. Okay, so we can easily see that XL is equal to XC, and as XL and XC are equal, therefore we can say that there is resonance condition in the circuit. So this is a resonance condition. So at resonance, we can say that VL will be equal to VC, and therefore in the magnitude, obviously they are equal in magnitude, and therefore the resultant of VL and VC, which is VL VC net, will be equal to 0. Okay, so the resultant of VL and VC will be equal to 0. So the reading of this voltmeter, which is connected across L and C, will be 0, and the reading of emitter, this reading of emitter will be, the circuit will behave like pure resistive circuit. Z will be equal to R. Okay, and R is 6. So current will be 20 by root 2, because this emitter will read the RMS value of current, and this voltage is the peak value of voltage. So we have to first of all find out the RMS value, which would be 20 upon root 2, and the value of R is 6. So this value of current will be equal to 5 upon 5 root 2 upon 3. It would be 5 root 2 upon 3, and obviously 5 root 2 upon 3 will be slightly greater than 1.6. So the only correct options which can be correct is B and A, and out of these two also we can select that A would be the correct answer, because uh, alone 5 by 3 is equal to 1.6, so it is greater than 1.4. So I guess A will be the correct answer. Now we move on the next question. In this question, you can see that there are three elements, in which one is capacitance, the other one is resistance, and the third one is the voltage source, AC voltage source. These three are connected in parallel to each other, and we have to choose the correct option regarding the phase differences between them. So to choose these options, we must draw the phasor diagram firstly, and we know that this is a parallel circuit, and in a parallel circuit, the quantity which is same for all of the elements is the voltage. So we will keep the voltage on the reference line, which is x axis, and we know that the current flowing through the resistance is in the same phase with the voltage. So we will be keeping I2 on this axis, and we know that the current flowing through the capacitance is ahead of the voltage by a phase of 90 degree. So we will keep I1 on this axis, and the resultant current I, which is the resultant of these two, will be at an angle of phi ahead of this I2 and V. So now let us choose the correct options. So the first option says that the current I2 and V are in same phase. So this is correct, obviously. So we can say that A is correct. Now second option says that current I1 lags behind I2 by 90 degree. This is wrong, because we know that I1 leads the I2 by 90 degrees, so it is wrong. Now current I leads I2 by an angle which is less than 90. So you can see that this current I leads the I2 by an angle phi, which is obviously less than 90. So this is also correct. And option D. Option D says that the current I leads I1 by an angle which is less than 90. So this is wrong, because I lags behind I1 by an angle which is less than 90. So the correct options in this question are A and C. Now let's move on the next question. In this question, you can see that there is a resistance and inductance and capacitance, and these are connected in series to each other. Okay, like this. And they are connected with the AC source. Now it is given that the voltage across resistance VR is 40 volts. The voltage across inductance VL is 30 volts, and the voltage across capacitance is 60 volts. And we have to find out the net supply voltage. So the net supply voltage will be under root of 60. See, we know that it is VC minus VL whole square plus VR square, है ना? And therefore the net supply voltage can be written as under root of VC minus VL whole square, which is 60 minus 30 whole square plus 40 square. So V net will be equal to under root of 30 square plus 40 square. So V net is equal to 50. So the correct answer is 50. Now we move on the next question. In this question, you can see that there is a circuit in which L, C, and R, all three are connected in series with a voltage source, this one. And the current which is already flowing in this circuit is 2.2 ampere. So I is 2.2 ampere. Okay, and the voltage, which is obviously RMS voltage because nothing is mentioned about this voltage in this circuit, in this question. So it is 220 volts. So Z will be equal to V upon I, and V upon I is 220 upon 2.2, and therefore we can say that Z will be equal to 100. And we know that R is also given as 100. So power factor is cos phi, and it is R upon Z. So R is 100 and Z is also 100. So power factor is 1. So the correct answer of this question is 1. Now we move on the next question. In this question, you can see that there is a series LCR circuit which is in resonance condition where omega naught is 1 upon root LC. We have to find out the quality factor of the circuit. So we can see we have already derived the quality factor, and it was 1 upon R under root L by C. This was the quality factor. And if you observe this option number 3, then if you replace the values, omega naught is 1 upon root LC, and this is L by R. So this is 1 by R under root L by C. So obviously the correct answer will be option 3. So in this video, these were the questions of level 1. And in the next video, I'll bring the level 2 problems on AC, which are for the JEE Advanced and Olympiad aspirants. So those who are aspiring JEE Advanced and Olympiad should wait for that next video, which will be released soon. Thank you.